So welcome to 11.6. We're going to be removing the greatest common factor, which is what? It is really the distributive property in reverse. So let's look at this. It says replace the question mark with the correct number to make the statement true. So what must have been out here that made 2x squared 14x and 20? Well, the question mark must have been 2, right? Right, so you were able, that's really what we're going to be doing today, figuring out what that question mark is there. It's distributive property in reverse. Now, let's combine this with a little factoring, right? So this is the last few days. We have a 10 here, and it's all plus, so it should be x plus 2 times x plus 5, I believe, equals that. And we're going to factor this. So you leave the 2, and then the other part is x plus 2 times x plus 5. Right? Because you're just factoring what's inside. Now, what about this? This is what we're going to be factoring today. Now, your first instinct, without my instructions, might be to do this, right? Well, it's a 20 here and it's a 2x. So you do 2x and x and 20. It could be 2 times 10, or it could be 4 times 5. It could be 1 times 20. We have a 14 there. And let's try 20 and 1, 10 and 2. Hey, let's try 10 and 2. All right, so at 2x plus 10 and x plus 2. All right, if I multiply that out with FOIL, you get 2x squared. Outer is plus 4x, inner is plus 10x, at last is 20, and that makes that. Those are the factors. There's a problem there, though. And what that problem is, right, that's not fully factored. Just like, say, 2/10 would never be allowed, right? You'd have to make that 1/5. 2x plus 10 is not allowed. There's a factor there. 2 and 10 have a common factor. So you would have to go again, just like if you say, right? So you have to take out or factor, my fault, you have to factor the 2 out and get x plus 5. And those are the complete factoring of 2x squared plus 14x plus 2. So you could factor it the way I did, but the way you're going to learn today is if you have that and you see that these are all divisible by 2, they have a factor of 2, take the 2 out right away. And the reason you want to take the 2 out right away, right, the question mark here is 2. So then, right, it'd be 2, right, 14 divided by 2, 7, 20 divided by 2, 10. All right, I took the 2 out. Then you factor what's left there, and you get the x plus 2 and x plus 5. Why do you take this 2 out at first? So this number here is 1, if it can be. It can't always be, because it makes the factoring easier. So that was all very fast, but I just taught you the lesson. We're going to do it again. All right, so if you're asked to factor this completely, you see that these all have a common factor of 2. You take that 2 out right away. All right, and then you have to figure out what would be left. Right, what would be left? Well, 2 times x squared, 2x squared, 2 times 7x, 14x, 2 times 10. That's what would be left, and then you just factor what's left. And now there are 3 factors there. One of them is 2, one of them is x plus 2, totally different, and another one is x plus 5. Okay, so let's try this, all right? So these are all even, so we're going to remove the greatest common factor. And then what's left is x squared, in this case 5x plus 6. Now, we're just going to stop there because it doesn't say factor completely. It says remove the greatest common factor. The largest number that divides into 2, 10, and 12 is 2. All right, so try this one. Hopefully we can see the largest factor is 3. What would be left? Because these are all on the 3 times table, right? X squared minus 2x, right? Because that would make the negative 6x minus 3. Okay. All right, so now, first of all, notice it hasn't said that before, factor completely. It's trying to clue you in that there is a greatest common factor to remove. That's what that word's telling you. So these are even, so we're going to remove a 2. We should get x squared, 16 divided by 2 is 8, so minus 8x. 15 divided by 30 divided by 2 is 15. All right, so we remove the greatest. So this is the step where we removed the greatest common factor. And now we bring the 2 along, don't forget it. Now we factor the rest like we have been. This is plus and this is minus, so these both have to be the same. And I think it's going to be 3 times 5 is 15, and negative 3 plus negative 5 is negative 8. And so those are the 3 factors, right? And so now we have factored completely. Okay. Right. If you went ahead and factored it, you could do 2x minus 6 and x minus 5. That's if I multiplied that there. But that's not factored completely. So that's why that 2x minus 6 can't be there. Right? Just like 2/6 can't be the answer to a fraction. Right? You have to get this 2 out at some point. The recommendation, get it out right away. Okay. So what do these all have in common? Now, these are all on the 3 times table, but there's a bigger one, right? 9. It's not always the first number, but the first number makes it easier. All right, so x squared, 9 times 8x is 72x. 9 times 7 is 63. We keep the 9, we bring it along. The fact these are all plus, and it's 1 and 7, and those are the 3 factors of 9x squared plus 72x plus 63. Okay, all right, 8 and 32 both have 8, so we have x squared minus 4y squared. Now this is a binomial, right? So whenever we have a binomial, we have that pattern, right? So x minus 2y, x plus 2y, I believe it is, x squared minus 2xy plus 2xy, right? The middle term drops out, and you get minus 4y squared. Those are the 3 factors. Don't forget about the 8. Bring it along. Right, so, right, the easy ones is where the largest factor is the first number. That's not the case here. 10 doesn't go into 35 or 15. So what is the largest factor? 5. All right, so figure out what would be left inside, right? 10, 35, and 15 are all in the 5 times table. So this would be 2x squared plus 7x plus 3. All right, so we have a 2 here, but it's all plus. So this is 2x and x. We have plus and plus, so we have to just figure out where the 1 and the 3 goes. I think the 3 goes there and the 1 goes there because we get 2x squared plus 6x plus 1x in the middle plus 3. And those are the 3 factors here. All right, so 12 is not the greatest common factor. 2 is, but I think there's one bigger. 3 doesn't go into 40. 4 goes into all of them. Is 4 the biggest? Well, 6 doesn't go into 40. 5 doesn't go into 12. 7, yeah. So it is 6. Okay, so it's 6. So this is 2x squared. No, it's not 6. What did I just say? It's 4. 4, so this is 3x squared minus 10x plus 3. And you can check that you have the correct one because 3, 10, and 3 do not have a common factor, right? If you took out 2, say, you'd get 6x squared minus 20x plus 2. These are all even, right? That can't be, right? So this is the correct one. And so we have 3x squared, so it's 3x and x. And it's a 3 and a 1. It's plus here, and so these are both going to be minus. And we're trying to get a 10, minus negative 10x in the middle. I think that's the one. 4 times 3x minus 1 times x minus 3. Okay, 18 and 50. What is the common factor? I think it's just, they're both even. I'm looking something bigger. No, 8, 7, 6, no. So I'm going to say just 2, and I get 9x squared minus 25y squared. So this is the difference of perfect squares. It's the only binomial we regularly factor in Algebra 1 here. And so 3x minus 5y, 3x plus 5y, I believe is the correct one. Okay, now the by the way, these are in ax squared plus bx plus c form, right? A so far has been positive, and whenever a is a negative number, which we haven't had mostly, you want to get rid of that negative because that being negative makes you have a headache in factoring. So you will always want to get rid of a negative here, even if it's a negative 1, okay? So here we're going to get rid of a negative 5, all right? So write what's left here after you get rid of a negative 5. Well, it'd be x squared plus x, right? The sign is going to change, minus 2, right? That's what will make that. We keep the negative 5, and the only way we're going to have one of each, and one of them is going to be 2, and one of them is going to be 1, and we're going to do x plus 2, x minus 1. Yeah, that's the correct factors. All right, so we have a negative, so we're going to bring out a negative number here. 6 doesn't go into 33, 2 doesn't go into 33, but 3 does. All right, so we're going to take out a negative 3, so this will be 2x squared. Then this will be plus 11x, and that will be plus 5. Okay, then we have to factor that. We've just taken out the greatest common factor, right? It's nicely all plus now, so we have 2x and x, and we have to figure out where the 5 and the 1 goes. Those are the factors. Negative 3 times 2x plus 1 times x plus 5. Okay, let's practice this. All right, is there a common factor? No, but there's a negative there. So in this case, take out a negative 1. It will make your life easier. So this is 5x squared minus 7x plus 2. This negative 1 stays out there. We have 5x and x, and it's going to be 2 and 1, and they're both going to be negative. So minus 2, minus 1. All right, we have a negative. We're definitely taking that out, and those are all in the 5 times table, so we're taking out a negative 5. So this is 2x squared minus 5x, right? These signs are going to change, plus 3. 2x squared, so we're going to have a 2x and an x, and we have both of them going to be minus. Which one is going to be the 3? Right there will be the 3. It's negative 5 times 2x minus 3 times x minus 1. And you can neaten this up. Okay, again, there's a negative, so take it out. You get x squared minus 4. Well, that's a difference of perfect squares, so it's x minus 2, x plus 2. Okay, so let's practice. So in these three, 6 or 3, no, 9. 9 is the biggest one, right? Because then, so we have 9, so that's 2x squared plus 5x minus 3. We have a 2x squared, so we have 2x and x. We have a minus 3, so we have a 3 and a 1, and there must be one of them be negative. I think this is going to be plus 3 and minus 1. Yeah. Over here, we're going to take out a negative, and what can I take out? Oh, I'm just going to take out a negative 1 here, I think. Yes, because it's going to be 16x squared minus 25. And then that's the difference of perfect squares. So 4x minus 5 times 4x plus 5, right? Because 16 and 25 don't have a common factor, but they are perfect squares. And right, we need the, by the way, we need the difference of perfect squares, right? This is the difference of perfect squares. Right? Each part is a perfect square. The whole thing is not a perfect square. The sum of perfect squares is not factorable normally, but with a negative, you can make it factorable. Negative a. Okay, final question. Factor completely. 20 and 45 both have 5, so 4x squared minus 9. Difference of perfect squares. 2x minus 3, 2x plus 3. Good luck on the homework.